Ahoy, printed parts. Ahoy, picture this. You're out at sea. Your ship needs a spare part, but you're miles from land. What do you do? In the past, you'd be stuck. You'd have to wait for ages for a replacement. But what if you could just print one? That's the promise of 3D printing in the maritime world. It's like having a magic box on board. Need a new propeller blade? Print it. Pipe sprung a leak? Print a patch. It sounds like something from Star Trek, but it's becoming a reality. This technology is changing how ships are built and repaired. It means less waiting, less waste, and more freedom for ship owners. We can now create complex parts on demand. This is a huge step forward for the industry. So, buckle up as we dive into the world of 3D printing at sea. Now, you might be wondering, how does this 3D printing thing actually work? Well, imagine a very precise glue gun. It lays down layers of material, one on top of the other, like building a cake but with metal or plastic instead of icing. This process is called additive manufacturing. We're adding material bit by bit to create a 3D object. It's like magic, watching a design on a computer become a solid object right before your eyes. 3D printing isn't just one thing, though. There are different types of 3D printing technologies. Each one has its own strengths and uses, but they all share that same basic principle, building things up layer by layer. And the best part? 3D printing allows for incredible precision and customization. We can create parts that fit perfectly, even for the most complex designs. It's a game changer for shipbuilding and repairs. The maritime industry has embraced a variety of 3D printing techniques. Each one caters to specific needs and materials. Let's dive into some of the most common ones. First up, we have fused deposition modeling, FDM. This method is like the trusty glue gun we talked about. It heats up a plastic filament and extrudes it onto a build platform. Layer by layer, it creates the desired object. Next, we have stereolithography, SLA. This technique uses a UV laser to solidify a liquid resin. It's known for its high precision and ability to create smooth surfaces. Ideal for detailed prototypes and models. Then there's selective laser sintering, SLS. This method uses a laser to fuse powdered material like nylon or metal. It's great for creating strong and durable parts. These are just a few examples of the 3D printing technologies making waves in maritime. Each one offers unique advantages, contributing to the growth and innovation in the industry. 3D printing wouldn't be possible without the right materials. Luckily, there's a whole buffet of options for maritime applications. Plastics are a popular choice. They're lightweight, corrosion-resistant, and easy to print. Perfect for things like prototypes, interior components, and even some structural parts. Metals are where it gets really exciting. We're talking about titanium, stainless steel, and nickel alloys. These are used for parts that need to withstand high stress and harsh conditions. Think propellers, engine components, and even parts of the hull. We can even print with composites. These materials combine the best of both worlds. They offer the strength of metal with the lightweight and corrosion resistance of plastics. Talk about a winning combination. As technology advances, we're constantly discovering new materials and improving existing ones. The possibilities for 3D printing in the maritime industry are only limited by our imagination, and perhaps by my understanding of material science, which is admittedly rather limited. Section 5. The digital Da Vinci's software steering the 3D printing ship. Behind every 3D printed masterpiece is a team of digital Da Vinci's. These are the software wizards who make it all possible. They use computer-aided design or CAD software to create the digital blueprints for our 3D printed parts. These programs allow engineers to design incredibly complex and intricate shapes. It's like digital sculpting, but with far more precision and control. Once the design is complete, it's sent to slicing software. This clever program slices the digital model into thin layers. Think of it like turning a loaf of bread into slices, but digital. These slices are then sent to the 3D printer as instructions for each layer. The software side of 3D printing is constantly evolving. New programs and features are being developed all the time. This ensures that we can push the boundaries of what's possible with 3D printing in the maritime world. Section 6. From Screen to Sea. The 3D printing process for ships. Now that we know about the materials and software, let's see how it all comes together. The journey of a 3D printed ship part begins with a design. Engineers use CAD software to create a digital blueprint of the part. This blueprint contains all the information about its shape, size, and dimensions. Next, the design is sent to the slicing software, which divides it into thin layers. Each layer is like a single frame in a stop-motion animation. These digital slices are then sent to the 3D printer. The 3D printer, following the instructions from the software, begins to build the part layer by layer. It carefully deposits or fuses the chosen material according to the design. This process can take hours, even days, depending on the size and complexity of the part. But once it's finished, you have a fully functional 3D printed component ready for action. It's like magic, but with more engineering and less glitter. Section 7, Real-World Wonders, 3D Printing Making Waves. Enough with the theory, let's dive into some real-world examples of 3D printing in action. Companies are already printing custom parts for ships. Need a replacement valve for your engine? No problem, just print one. How about a new propeller blade? Easy peasy, print it. 3D printing is even being used to create entire sections of ships. Imagine printing a whole hull section. This could revolutionize shipbuilding, making it faster, cheaper, and more efficient. But it's not just about building new ships. 3D printing is a game-changer for repairs too. Imagine a ship stranded at sea with a broken engine part. In the past, this would have been a disaster. But with 3D printing, they can potentially print a replacement part on board and keep on sailing. Section 8. Charting the Uncharted. The future of 3D printing at sea. The future of 3D printing in the maritime world is vast and exciting. It's like the open ocean, full of possibilities. Imagine ships equipped with onboard 3D printers. They could print spare parts on demand, reducing downtime and reliance on shore-based supplies. Talk about self-sufficient sailing. We could see 3D printed drones and underwater vehicles used for inspections and repairs. These robots could access hard-to-reach areas, making maintenance safer and more efficient. And who knows, maybe one day we'll be printing entire ships at sea. It might sound far-fetched now, but so did the internet in the 1980s. The possibilities are endless, limited only by our imagination. And perhaps by my ability to come up with more nautical puns, which is frankly starting to feel a bit strained. Section 9. Choppy waters challenges on the horizon of 3D printing. While the future of 3D printing in the maritime industry is bright, some challenges need to be addressed. One of the main challenges is scalability. Right now, 3D printing is great for producing small to medium-sized parts, but scaling up to print entire sections of a ship or large components is still a challenge. Another challenge is the cost. While the price of 3D printing has come down significantly, it can still be expensive, especially for large-scale projects. Then there's the issue of material properties. While we can print with a variety of materials, they don't always have the same properties as traditionally manufactured parts. More research and development are needed to ensure that 3D printed parts can withstand the harsh conditions at sea. Finally, there's the need for industry-wide standards and regulations. As 3D printing becomes more common in maritime, it's crucial to have clear guidelines and standards to ensure safety and reliability. Section 10. Fair winds and following seas. 3D printing's bright future in maritime. Despite these challenges, the future of 3D printing in the maritime industry is incredibly promising. It's like a ship with its sails set, ready to catch the wind. As technology continues to advance and costs decrease, we can expect to see even wider adoption of 3D printing in shipbuilding and repairs. This technology has the potential to revolutionize the industry, making it more efficient, sustainable, and cost-effective. It can empower ship owners and operators with greater flexibility and independence. So there you have it. 3D printing is transforming the maritime world one layer at a time, and as we continue to explore its potential, we can look forward to a future where the only limit is our imagination. Now, if you'll excuse me, I need to go and find a maritime dictionary. I'm all out of puns.